Hi, today we're going to talk about 4.5 global wind patterns. Take a moment, check out the Enduring Understanding, look at the learning objective, and pause the video, review the essential knowledge, and set up your Cornell notes. So before we talk about this, we need to know that all of this is controlled by the sun, the solar energy. And remember, the solar energy is the most intense in the tropical regions between the Tropic of Cancer and the Tropic of Capricorn. So roughly like between 23 degrees northern and southern hemisphere. So this little area like around the waistline of the planet is the warmest. Now this means that the temperature will be the hottest there. Now think back to when we talked about convection currents. Convection currents involve moving from warmer to colder areas. And what happens is this warm air at the equator is less dense. So it's going to rise up from the equator. And the air is going to rise up at the troposphere, and it's not able to pass the tropopause. So it's going to rise up and move apart, just like it did in the inside the surface of the Earth when we're talking about the tectonic plate activity. So the warm surface air rises, and then it's going to cool. And whenever air gets colder, it holds less moisture, and that causes rain. So we have huge amounts of rain all throughout the equatorial regions. And this is why if you look on the globe, all of the rainforests are found in the equatorial regions. We have the Amazon rainforest, we have the Congo Basin rainforest in Central Africa. We also have Southeast Asia, we have Indonesia and Malaysia where we have rainforests as well. So what happens is, after that rain has fallen, the air currents continue moving north and or south, and the cool, dense, dry air is going to sink. And since this air is sinking, we have deserts that form at 30 degrees north latitude and 30 degrees south latitude. The Sahara Desert, the Sonoran Desert, the Chihuahua Desert, the Gobi Desert, the Atacama Desert. All of these deserts are for Australia. All of these deserts are forming at 30 degrees north latitude and 30 degrees south latitude because we have this cooler, doesn't mean it's cold, it's cooler than it is at the tropical, but it's dense and it's very dry. So this dry air is sinking, and this is contributing to the formation of deserts. Now, some of the air is going to return back to the equator where the pressure is low. So it's going to kind of be sucked into that space where the air needs to be replenished. But some of it will also, the warm air will also move towards the poles, and the poles are cooler. We have the North Pole over here. It is going to move towards the cooler poles. Then something else happens. Then this low pressure air is going to rise at 60 degrees north latitude and 60 degrees south latitude. It's going to cool again and sink at 30 degrees north and 30 degrees south latitude. So here we have two currents that are coming together, and here we have two currents that are going apart, very much like we have in the mantle inside the Earth's surface. Now, the high pressure polar air, because it's cold, dense, very high pressure, is going to sink and flow towards 60 degrees latitude north and south, but it doesn't mix well with the warm air, so it's going to rise. Now, when this is all said and done, we have 3 cells. And really what you have to know is you got to know the Hadley cell. I mean, I would just memorize them. Ferrel cell, I really haven't seen the Ferrel cell you being required to know the name. I'm not saying you don't have to know the name, but if I was placing my bets, I would bet learn the Hadley cell, then learn the polar cell, then learn the Ferrel cell. So if you have to choose, Hadley's the most important. The polar cells are easy because they're at the north and the south pole. We will be doing an activity in class where we're going to be mimicking some of this movement, and you'll see exactly what we are talking about. But this is the general trend in the convection currents on the planet. At the equator, we have air rising, so this represents little arrows. So it's showing you the direction that these are moving. Is this all that important? No, it is not. You will definitely see this image again. Know that dry air is falling back to the Earth at 30 degrees north and 30 degrees south latitude. Those are the most important things. And then remember that the air is rising at the equator. That's important. You can construct the rest of the currents based on that. Now, why does this all happen? We have these wind patterns because of the Coriolis effect. So because the Earth is spinning, imagine throwing a baseball from, let's just say you had the super great strong arm and you could throw a baseball from the North Pole down to Brazil. Okay, and you were throwing it in a straight line. Well, because the Earth is spinning, as you're throwing the ball, your ball is actually going to be deflected. So the Earth is spinning clockwise, and if you throw it straight down, it's actually going to veer off a little bit and looking to the left. We're going to be doing an activity in class that's going to mimic this, but the Coriolis effect, in conjunction with these convection currents, has impact on the surface wind patterns. These are the trade winds that are blowing against the equator. And then in the temperate regions, they're actually blowing to the northeast. And we kind of see that because a lot of our weather comes from the west. In fact, if it's like raining, if it's raining in Minnesota, where I call my mom, and my mom will say, oh, it's raining, or it's 70 degrees here today, a lot cooler than it was yesterday. Well, then a couple days later in New York, we kind of have similar weather. If we have remnants of a tropical storm, it'll come from the Gulf Coast and it'll rise up through the south and up to the northeast, and it kind of has this pattern. And these are the basic surface patterns, and they're due to the convection currents and the Coriolis effect. Now, you can also see it when you have a typical Atlantic hurricane season. I don't recall what year this was. This might have been 2019. I think it was 2019. But the hurricanes are forming over here in Africa. The equator is farther down. But remember, these wind patterns are blowing towards the equator. And one of the things that you notice about hurricanes is that hurricanes will never go past, they will never go too far south where they will go south of the equator. If a hurricane forms in the northern hemisphere, it stays in the northern hemisphere because these wind patterns can't cross the equator because you have other winds pushing up towards the equator. So they're kind of converging at the equator. It's not possible for this to pass the equator. Now, once it blows over here and makes it to landfall, you get up past 30 degrees north, and then it starts moving to the northeast. So this is the typical pattern, and it's based off of this. So it's going this way, and then it starts going up, and then it gets caught by these wind currents. So these are basic wind patterns. The extent that you have to understand this is really based on, or it's really related to other topics that we will be discussing in upcoming lessons. I want you to tell me what you've learned in this FRQ practice. I want you to explain how the sun is responsible for the atmospheric circulation patterns that are shown in red. So formulate your response, and I thank you for your attention. I hope that this was informative. I will see you soon.